Okay, I wanted to look at this problem about plotting 3 points and deciding whether they are coming together to make a line. So points that are on a line, sometimes you call them collinear, just means they're together on a line segment. So if you're taking these 3 points, and Joseph said, I think they lie on a line, and Catherine says, I don't think they do. One way you can check it is if they follow the same slope, then you say they're collinear. So to find the slope, you have to figure out the vertical change, which the vertical change is going from the number 1 to 7. And finding out how something changes means you would subtract. So from 1 to 7, that gives you a change of 6, compared to the horizontal change, which is going from 2 to 5. So my new number is 5 and my old number is 2, and that gives me a change of 3. So this is giving me, when I simplify it, a slope of 2. Now, if the other set of points gives you a slope of 2, then you would say they're on that same line segment, so you'd say they're collinear. So first find the vertical change. So I'd have to do 18 take away 7. That gives you 11. And then the horizontal change, you're going from 5 on the x-axis to 11. So 11 take away 5 is 6. Well, 11/6 does not reduce to 2, so even though they kind of appear to be collinear, they're not, because the slopes are not the same. So when I'm going back to this first page, and if they want to say, make sure that these are on the same line and figure out what the missing pieces are, then you can set it up using proportions. This rise and run is 6/8. So in order for these 2 points to be on the same line, this proportion has to be equal. So its rise is 9, and its run is, I don't know, so they call it A. So on this piece, you could go and you could solve the proportion by doing the cross products. So you've got 6 times A, which I know my A looks like 9, so I'm going to put 6A, capital A, to make it look a little different, is equal to 8 times 9 is 72. Then you could take a calculator and take the 6, since it's a coefficient, you would have to divide it off, and you would end up getting 12. So it's about going back and solving for these equations and figuring out what the missing piece would be. That would be 12. Now, sometimes you may have to find the rise, where in this case you had to find the run. But all of these triangles, if you're asking, like, what's the relationship, they're not all the same size, but their side lengths are proportional. So if you have that case, then you would call that being similar. So those are similar triangles that we have there. So on this MFAL, where you're trying to sort the set of lines, you've got points. So you're going to have to find the slope, and then you're going to have to find a card that matches with it that has the same slope that would go through that same point. So you're going to have to do a little bit of work where if you're actually trying to figure out the equation of a line, for example, this one says, what's the equation of the line that goes through the point 2, 1, and 5, 7? So we've already looked at the slope was 6/3, and 6/3 gave you a slope of 2. So on the slope-intercept form, it's always written as y equals mx plus b. So the slope and the m is the same thing, so I can put this in place of the m. Now, pick one of the points. It really doesn't matter which point you pick. I'm just going to pick the 2, 1 because that's the smallest numbers. So in place of the x, I can replace the x with a 2. In place of the y, I can replace a y with a 1. And the only variable that I don't know what it is the missing b, which is where it begins on the axis. So you've got y equals 4 plus some b. So I'm doing inverse operations. To figure out the b, I got to get rid of the add 4. So I subtract 4, and I get b is equal to negative 3. So if I had to graph this on an xy axis, this line would start at negative 3 on the y-axis, and it would have a slope of 2, which would mean go up 2 and over 1, then you go up 2 over 1, and your line would look like this. Now, two things that's never going to change about this line is the B, where it crossed this y-axis, that's never going to change, and how the line moves. It's always going to go up 2 and over 1. What does change is if I pick different points on the line, then it's going to change the x and y coordinates. So they may ask you, are they on the same line? So in this MFAL, you're trying to choose two cards that match, that where they would have the exact same equation. So you may have to do some of this work right here to figure out if they're giving you the 2 points. Not only are you going to have to find the slope, but you're going to have to find the beginning of that line. So again, as all the other MFALs, I would probably not do this individually. I would work on a partner with it, or a group of 3 or 4 if you have somebody. So good luck.